Hello and welcome to mathandsciencepower.com. My name is Joe and I'll be your host. Please remember that you can help me to help you by subscribing to my channel, commenting on the videos, and rating and sharing the videos with your friends. Also remember to visit us online for a complete listing of our videos. Okay, let's talk about a simple Atwood machine, which is basically a pulley with a rope draped over it and a mass hanging from each rope. Okay, and we're going to call these mass A and mass B. And let's say that the masses are known, and mass A is 10 kilograms and mass B is 12 kilograms. Now, as you would imagine, this mass is more, and so the pulley is going to turn in a clockwise direction, and this mass is going to fall to the ground and this one's going to come to the top. We're going to experience some acceleration in this direction, and we'll call that the acceleration of the system. Okay. Now each block has two forces acting on it. The first is the weight of the block. So here's the weight of A, and that is going to be equal to the mass of the block times gravity, which will be 10 kilograms times 9.8 meters per second squared, and that gives us 98 newtons. The other force that is acting on this block is the tension in the rope, and for now we don't know the tension, so we will call that T. Okay, and block 2 is very much the same. Two forces, the first being the weight of B, which is the mass of B, times the acceleration due to gravity, which is 12 kilograms, times 9.8 meters per second squared, and that gives us 117.6 newtons. And again, the other force here is the tension in the rope. Now, because of Newton's second law, the tension in the rope must be equal everywhere. In opposite directions. The tension in the rope here is the same as the tension of the rope here, even though the masses are different. So the tensions are equal. Okay. So there is a net force acting on mass A, and the net force on A is equal to the mass of A times the acceleration of the system. Okay, Newton's second law, the force on this block has to be equal to its mass times its acceleration. Even though the gravitational acceleration is 9.8, the block is not actually going to be falling with an acceleration of 9.8. We actually expect it to rise. So the force on A is equal to the sum of the forces that we know here. Okay, and the first is the weight and the other is the tension. Now, because the acceleration is in this direction, we're going to be calling this direction positive. T is in the positive direction. So the force on A is T, and the weight of the block is in the other direction. These are the two forces on this block. So minus the weight of A. And this will equal the mass of A times the acceleration of the system. And similarly, for block B, we also know that the force on B is equal to the mass of B times the acceleration of the system. Newton's second law. The force on this block has to be equal to its mass times its acceleration. And the force on B is equal to the sum of these two forces, the two forces acting on B. And since the acceleration is this way, WB is taken to be positive and the tension is taken to be negative. So the force on B is equal to the weight of B minus the tension in the rope, which has to equal the mass of B times the acceleration of the system. Okay, now to solve this equation, we have two unknowns here. The first one being the tension, and the second one being the acceleration of the system. But luckily we have two equations so we can solve for two unknowns, and I'm going to use the method of substitution. I'm going to solve both equations for T I'm going to add the weight of A to both sides here, and I'm going to get T equals the mass of A times the acceleration of the system plus the weight of A. And here I'm going to subtract the weight of B from both sides, and I will get negative the tension is equal to the mass of B times the acceleration of the system minus the weight of B. And I want this to be positive, so I'm going to multiply both sides by -1. So this becomes positive T, and this -1 distributes, so this will be negative mass of B times acceleration of the system plus the weight of B. Now I have two equations that are both set to equal to T, so since this equals T and this equals T, this means that these must equal each other. So I know that the mass of A times the acceleration of the system plus the weight of A equals the negative mass of B times the acceleration on the system plus the weight of B. And this is the equation that we need to use to solve. We only have one unknown now, and that's the acceleration of the system. We know the mass of A, the mass of B, the weight of A, and the weight of B. So take a moment, see if you can plug in the numbers, solve the equation, and we'll come back and check and make sure that we get the right answer. Okay, welcome back to mathandsciencepower.com. My name is Joe and I'm your host. Please remember that you can help me to help you by subscribing to my channel, commenting on the videos, and rating and sharing the videos with your friends. Also remember to visit us online for a complete listing of our videos. Okay, so we have our equation that we can solve for the acceleration of the system, and all we have to do now is plug in our numbers. So the mass of A is 10 kilograms times the acceleration of the system, which is our unknown, plus the weight of A, which we solved to be 98 newtons, and this equals the negative mass of B, which is 12 kilograms, times our unknown, the acceleration of the system, plus the weight of B, which we solved earlier to be 117.6 newtons. Okay, so I want to get my terms with the unknown AS on one side of the equation and my constants, which are 98 newtons and 117.6 newtons on the other side. So I'm going to subtract 98 newtons from both sides. Okay, I'm also going to add 12 kilograms times the acceleration of the system to both sides. Okay, these 98 newtons here will cancel. This 12 AS and this 12 AS will cancel. And over here I get 10 plus 12, which is 22 kilograms times the acceleration of the system, combining those terms, equals, and 117.6 newtons minus 98 newtons, that comes out to be 19.6 newtons. Okay, I divide both sides by 22 kilograms. 22 cancels here, leaving me with the acceleration of the system, and 19.6 newtons divided by 22 kilograms gives me 0.89 meters per second squared as the acceleration. So we just solved for the acceleration here, and we decided that it is 0.89 meters per second squared. Okay, now that we know the acceleration, we can plug that back into one of our original two equations and solve for tension. And this one seems easier because it's already solved for tension here, and it's positive, and it just seems the easiest. So the tension equals the mass of A, which is 10 kilograms, times the acceleration of the system, which we just solved to be 0.89 meters per second squared, and we have to add the weight of A, which is 98 newtons. Okay, so tension equals 10 times 8.9, or 0.89 is 8.9, and that's newtons, kilograms times meters per second squared, plus 98 newtons. So we get that tension equals 106.9 newtons. So we solved for the acceleration of the system and the tension in the rope. Okay, my name is Joe. Thanks for watching.